Good afternoon. Okay. Well, we had two very excellent speakers before me who basically talked about the effects of a, whatever you want to call it, an event and how we come out of it. Basically, they talked about how to recover the resilience required to continue with the business practice. Now, you can plan for what you know, what you understand, what you can quantify, and that's what I'm trying to talk to you about. See, basically, I want to talk to you about identification of credible incidents. What I mean to say is, well, the best laid plans of mice and men, etc., anything can go wrong. You design a good plant, you operate the plant properly, you think you're good, maybe you feel you're good, you have reason to believe you're good, but then something strikes you. Now, whether you should have been aware of it, whether you should have planned for it, it's beside the matter. The act has happened. Now, the question arises, what is the level of risk that you're prepared to take? Okay, we've all heard terms like LAP, as low as, reasonably practical, etc. But there is always a need to build a response system for an emergency and for a recovery. So for this, what I want to tell you is how you go about defining what is the crisis that you can plan for. I mean, you can't plan for everything. Like, for instance, you can't plan for a meteorite striking your facility. But you can plan for an earthquake. You can plan for a tsunami, or a combination of the two. If you don't do that, you're failing. You're not being fair to yourself. Meteorite, you can't do anything about it. Anyway, we're all dead after that. Don't worry about it. So, the Center for Chemical Process Safety, which I happen to represent here, has been talking about these aspects. It has been at the forefront of process safety and has developed a fairly wide and comprehensive body of knowledge. Very often today, some planners talk about worst possible incidents. Like suppose you have a refinery with a huge tank farm. I mean, it's nobody's case that every bit of inventory in the tank farm can go up and fire at the same time. Yes, you can, what you can call, estimate it. You have enough number of computer tools nowadays available. Take the entire inventory in the tank farm and say it's all going up in smoke in one shot. You can get very logical graphs, pictures, numbers, but is it credible? That's a question you have to ask. It's very easy to postulate. It assumes that all your protective barriers are going to fail. Please understand, I'm still saying that it is possible. That means the probability is not exactly zero, but it's very unlikely. It's not probable. And I think as engineers, we have to realize that these kind of incidents we should not really plan for. Maybe somebody might not like this what I'm saying, but that's what I believe. Why? Because this would lead to a misapplication of resources. Please understand, resources are limited. I mean, you can't plan for everything that is there. So you got to realize, and you got to act, and you got to basically understand what is likely to happen and what you can do to prevent it from snowballing into a catastrophe. That's the only thing you can do. It's nobody's case that risk is absolutely zero. It should not be. Because if you start spending your resources on chasing unlikely devils, you will miss out what can really happen to you in the plant. Yeah. Now, a worst credible catastrophe is more logical, is easier to implement, and it also assumes that your layers of protection are going to work, and emergency response in itself is one of the layers of protection. What in CCPS parlance is normally referred to as RAGAJEP. That is recognized and generally accepted good engineering practice. We are talking about that. Okay? Now, how do we screen for likely events or credible events? I mean, I'm not going to give you what you can call a worksheet on how to do it. I'm just more or less recapping what I presume this entire audience is aware of. You have the NFPA fire indices, the NFPA diamond, which is very simple. It gives you a very clear idea as to what can happen. Then you have the toxicity, mobility and quantity index and chemical risk indices, which I'll briefly touch upon. Let's take first the NFPA diamond. I think we all know what this is. I will not go further into this. That is, anything normally beyond 2 is something which you need to address. Of course, what I want to say is the NFPA diamond has got it's very simple, easy to understand. It has its drawbacks. The quantity is not mentioned anywhere. Whether you're talking about 1 liter of gasoline or a tank for 100,000 meter cube of gasoline, you don't know. Then you have this substance hazard index, API 750. This definition is there. It talks about acute toxicity. Acute toxicity data are available, or if they are not available for a substance which you have, something similar is definitely available in various places, somewhere or the other. You can always get it. It uses emergency response planning guidelines. Then you have the IDLX that immediately dangerous to life and health. Then LC10 which you use, which is basically 1/10 of LC50 to come across your ATC numbers. All these give you some idea of quantification of your risks, or qualification of your risk. Quantification comes this way, sorry, beg your pardon. Then you have these chemical risk indices pioneered by Dow, basically the Dow FNEI, which is a function of both the vapor pressure, the flash point, and the operating pressure and temperature at which you are operating. Please, this is the difference between this and the NFPA diamond. The actual conditions are also parameters in your determining the fire exposure index. Similarly, you have the CEI, where the relative rate of discharge in case of a failure, the quantity in the air and other such parameters are also incorporated into your numbers to get the CEI. Now the advantage of CEI and FNEI indices is they're not absolute, they're not perfect, but with this you can compare, say, a small tank with a large tank. It at least gives you some idea that all tanks are not equal. It not just talks about just the material, it also talks about the inventory. Then, having come this far, you have to talk about techniques for identifying credible incidents for emergency planning. Now this is what I basically want to talk to you about. Already taken up 10 minutes, 30, okay. First is the informal expert review. That is, you get a set of experts, ask them to look at the documentation in the plant. See, please understand one thing. For selecting credible incidents, you are not at least prima facie talking about doing a detailed development of any documentation. You have to primarily work with the documentation you already have, because a lot of effort has gone into that. You look at those documentation and then decide where you stand and how you improve upon it. I'll come to a bit later. So you take an informal expert review, you see what you got in hand, and then what you do is you do it by brainstorming, walk through, generate a list of potential incidents, and you postulate loss of primary containment in vessels, all the vessels you can take. Just you list out what you have, what can be the worst case scenario. Not necessarily worst plausible, just the worst case. Then you check with various generic LOPC cases. It's available all over the world. These indices are there. You can work it out. And then you filter out the trivial issues and concentrate only on the things which are likely. This is one way of doing it. You want to be slightly more rigorous? You go to a hazard review. That is, you review all the hazard situations that you have. You drill down, look at the PFDs, look at the hazard identification systems that you had. Take incident case histories. A lot of databases provide you case histories, for instance. Even CCPS has got its own PSID, they got PERD, so on and so forth. I'm sure other organizations also have something similar to this. And then you rank the risks. Now, finally you have what you would call a process hazard analysis. You can use the data obtained or see what has been done earlier. Start with the simplest. Start with the what if that exercise has been done. Go to the checklist, go to the hazard, go to the FME, FDA, what has been done. I'm not saying at this stage you should do anything. You look at what has already been done and take information from there to make your emergency planning systems. Now, this is in graphic form the same, okay. How you prioritize for consequence assessment. See, basically the idea is you want to find out a basis for prioritizing what can be the consequence. Based on the consequences, then you decide what can be a credible incident and then work towards that. So you have, from the list, you screen to selected and limited numbers. Okay, I'll read from my text here, it makes it much simpler. Okay, now, yeah, you see, these are what you would call, first you take all possible incidents, one. From that, then you go down to an initial list, a revised list, a condensed list, an expansive list, a representative, and then bounding group. So what you do is, one, to get at all possible incidents, you take an infinite number of possible incidents of various sizes, everything. Basically, you maybe do it by a walkthrough or whatever. Then from there, you cull down by some form, by looking at the results obtained from some form of hazard analysis. I mean, I'm not being specific about what type it is. Some form of hazard analysis will give you some method of reducing the number of incidents. See, the basic idea is you got to have a number which you can work with. Then you go further down, removal of incidents with low consequences. That's number 3. Then you come to the fourth list, condensed list. Combine similar incidents with similar consequences. I mean, you have a tank farm, normally anybody logically does this, you put things off in the tank farm, you will not store crude, let us say, with gasoline. And it's already been done. Because if somebody designs a plant, this has already been done. So you go by that kind of bounding. And finally you drill down based on incidents which you want to select for the EP study. Then you get representative subsets of incidents considered, and finally you have incidents of the highest consequences. This way, you can bring down to a manageable number Just like you would do in the case of, let's say, what is safety critical equipment in the plant? Every equipment? Every safety valve? No. You have to bring it down to a reasonable number, maybe 5 or 10, which you think are safety critical. And then you work with that. Similarly here, you take what is likely, not just what is possible. Yes, and of course this, okay, I'll skip this. This what you know, what you want to plan for. Again, this has already been done. See, I'm talking about a plant that's already existing probably, at least on paper. All this has been done. So you decide where you want to attack. And what has been done to bring the red into the yellow, and the yellow into the green. Then basically when you want to select for emergency response planning, you ignore localized incidents. Consolidate redundant or similar response needs. And then finally, this is a suggestion, you take one major incident and one credible worst case. Work only with this. This is manageable, it is doable, and you need to do. So now you come this far. Now what happens next? So you've done all this exercise and come here. Then what you need to do, you have to assess consequences and impacts for all of them. Toxic release, fire, explosion. And tools are available today for dispersion modeling, so you can understand the impact outside your plant on people, property, and any other, like say, environment. Finally, what you do, you have to review your assessment. You come to one end, you go back. See whether you can reduce it further to a more logical number. That is, you revisit after your first review, then revisit at a designated interval. Because as you go along, I think you also tend to understand your plant better. So you have to have designated intervals in which you plan what should be your emergency response. And of course, whenever you're going for any change, as part of your MOC, you must do an evaluation of your emergency response plans. Okay, and before I go further, this information which I provided is not original. It comes from one of the CCPS books, Guidelines for Technical Planning for On-Site Emergencies. So with that, I think I have not exceeded. Ladies and gentlemen, I am done. Thank you so much.